Good morning, students. So in the last class, we completed with the chapter chemical bonding. So in the today's class, we are going to start with the new chapter, that is another chapter from organic chemistry. Very important. Okay. So that is hydrocarbons. So what are the objectives we are going to study in this is only the 5 objectives. One is for your syllabus, classification of elements, Another one is in that hydrocarbons we want to study about alkynes individually, aromatic compounds, and also carcinogenic nature, or if you want to take, that is carcinogenicity and toxicity. These are the topics remind for your syllabus. Okay, classification of elements, alkenes, aromatic compounds, and carcinogenicity and toxicity. Okay, so let's discuss one by one. So students, the classification of the elements, that is matter, and it is converted into somewhat. I already discussed in what? The first chapter, very first chapter, some basic principles and some basic concepts of organic chemistry. In that I already explained, matter is there, that matter is divided into classified into pure substance and the mixture. Pure substance is further classified into element and the molecule. Okay, and the mixtures are classified as homogeneous and heterogeneous. In that element, compound is there, atoms are there. So in that compound, inorganic is the organic is. Okay, in that organic, again types. Here the classification of organic compounds we are going to study. So just take this classification of organic compounds. Okay, so we will discuss with one by one. Okay, so students, of course, as I told you, the compounds are also organic compounds, especially organic compounds are also of 2 types. One is aliphatic, another one is aromatic. Or you know that cyclic and acyclic. In cyclic, alicyclic will be there, aromatic will be there. You know that in aliphatic only alkanes and alkynes will come. Okay, so aliphatic and aromatic. Or you take, instead of aliphatic, aromatic, you directly take. This is cyclic, acyclic. Acyclic means there is no cycle, there is no closed structure. So these are aliphatic. Which are comes here? Alkanes, and alkynes. These are the examples for aliphatic compound, straight chain. Okay, aliphatic means, you may write, those are straight chain compounds. Okay, so in this cyclic 2 types is there. One is alicyclic, another one is aromatic. Okay, so alicyclic means cyclic or cycloalkenes or cycloalkynes. Are you getting? Means the close ring which resembles the property of alkane, alkene and alkyne. Cycloalkane, cycloalkene and cycloalkyne. And aromatic means the purely benzene ring and its compounds. No noting that is aromatic. So for your syllabus, we are going to study only aromatic and aliphatic means alkanes, and the aromatic compounds. This cyclic we won't study in this chapter because in the last chapter means the previous chapter of organic chemistry we already studied in nomenclature everything. What are these cyclic compounds? How they behave? How the nomenclature will done. Okay, so we are going to this. So students listen, this aliphatic again classified as saturated and unsaturated compounds. Saturated and unsaturated. Listen, saturated means single bond, unsaturated means double or triple bond. Means alkanes are saturated hydrocarbons, alkenes and alkynes are unsaturated hydrocarbons. This is the classification. So in the before chapter we studied what are alicyclic, what are aliphatic, what are aromatic. What are aromatic compounds with an example? What is alicyclic with an example? What is aliphatic with an example? We already discussed in the previous chapter. Previous means not chemical bonding, okay? So some basic principles and techniques in organic chemistry. The first chapter of organic chemistry, we already studied that. So we will continue with the saturated, unsaturated, aromatic, and this means aliphatic and aromatic. Okay? So let's discuss. Okay, so listen. In that first one is saturated hydrocarbon. Okay, so this is saturated hydrocarbon means carbon the compounds having carbon single bond and carbon hydrogen single bond are called as saturated hydrocarbons. Okay, so what is the reason for that? Why we are using the word saturated? Okay, listen, for this example, alkane. What is the formula of alkane? Cn H2n plus 2. Okay, why these are called as saturated means listen, here carbon is there. To this carbon, consider methane, that is CH4 molecule. No one extra atom can, because carbon is tetravalent, 1, 2, 3, 4 bonds satisfied. Hydrogen is monovalent, means only one bond it can be formed. So all the hydrogens are satisfied with one bond. There is no extra atom to be added to this compound. Next, if you take ethane, carbon-carbon single bond is there, and also carbon-hydrogen single bonds are there. Here to this compound, we cannot add any extra atom. We can replace. This H is replaced by any other atom like Cl. This H is replaced by F. Okay, H is replaced by OH. We can just replace, substitute, but we cannot add. So by removal of this H, we can add OH. By removal of this H, we can add Cl. But this extra atom cannot be added to this type of compounds. Means they are satisfied with their valency. That's why the word saturated is used. What it suggests saturated means it is already fulfilled. There is no one extra atom can be added to this type of compounds. Are you getting? So next, if we take unsaturated, second one is unsaturated hydrocarbons. Means the compounds consist of carbon, multiple bonds and carbon, hydrogen, single bond are called as unsaturated hydrocarbons. So students, why I am writing, if I can easily explain, but why I am writing means these are very important for examination. Tell us what is saturated hydrocarbons, give an example. What are unsaturated hydrocarbons, give an example. Okay, so example for this is what I do. Alkanes are the examples of saturated means alkenes and alkynes are the examples of unsaturated hydrocarbons. Okay, so I'll take the simple example of alkene here, that is ethene, C double bond C. This is H, 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 H. Correct? So listen here, double bond is there. Are you getting? Here, double bond is there. Here is the carbon-carbon multiple bond. Single bond is the sigma bond. Okay. Of course, here two bonds are there means they are multiple bonds. More than one. Okay. So carbon-carbon multiple bond and carbon-hydrogen single bond. So this type of compounds are example for unsaturated hydrocarbons. Unsaturated. Why? So listen. If any atom to be added extra, for this atom, if we add hydrogen here, in presence of any platinum or palladium as a catalyst, okay, then of course it forms, here double bond is there. So this double bond is removed by the addition of extra hydrogen atoms. Now it is satisfied. Why these are called as unsaturated means the atoms can be added to this multiple bonds. Multiple bond can convert it to what? Single bond. So after the formation of the single bond is alkanes. Alkenes may be converted into what? Alkanes. Whether I am telling only hydrogen here. I am not saying. So this is one example reaction that of course the atoms can be added to this type of unsaturated compounds. You may take Cl2 here. Okay. You may take H2O here. Whatever it may be. If you take H2O, one will get H, one will get OH. If you get Cl2, both atoms will be substituted with Cl. Are you getting my words? So instead of here, if you take Cl2, here it is sunlight. Then here instead of H, Cl will be there. Understood? So if you take H2O here in presence of dilute H2SO4 acid. So one carbon will get H, another carbon will get OH. Understood? So this is what I'm telling only about extra atoms to be added to this type of compounds. That's why they are called as unsaturated. They are not satisfied. That's why they add atom to them. This is alkane. If you check alkene to alkane, are you getting? So if you want to take example of alkyne, that is CH triple bond CH. So students, if H2 is added here, I'll take simple example. Okay, then here multiple bond is there. So one bond is removed by the substitution of two hydrogen atoms. This alkyne changes to what? Alkene. Again, H2 to be added in presence of platinum and palladium. And then you see H, 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 single bond, C, H, H. Overall, if you want to write, to this 2 moles of H2 is added, then directly alkane will form. And right here is in C triple bond CH. Here 1 mole, here 1 mole. Means 2 moles of H2, same in presence of platinum or palladium. So we will get this type of compound. It is alkene. Okay, so means this alkene and alkyne prefers the addition of atoms. That's why they are called as unsaturated hydrocarbons. Okay, here they cannot prefer the addition of the atoms. They just replace the atoms. That's why they are unsaturated hydrocarbons. Okay, so students remember, always this alkenes and alkynes undergoes addition reaction. Remember that. Always this alkene and alkyne undergoes addition reaction. Means atoms are added to this. This one undergoes substitution and elimination reaction. Substitution and elimination, most preferable reaction. Substitute, replace one atom by another atom. You know the word substitute. Elimination, by eliminating some compounds, they will form alkene and alkene. Understood? So this is all about aliphatic classification. It means aliphatic compounds, two types, saturated and unsaturated. This is the another one is aromatic. You know, I already explained about aromatic. If any hydrocarbons consists of at least one benzene ring, understood? The compound consists of at least one benzene ring, that is said to be an aromatic hydrocarbon. So students, we cannot see them, you know, organic compounds, whatever it may be. It may be ethanol, okay? It may be alkene, alkyne, or methane. Especially methane, ethane and propane are the gases. You know that methane gas will extract from gobar. Methane gas, which is what is gobar gas always we are used for cooking, you know that technique. Okay, so that is what methane is produced from that gobar. We cannot see gas. Okay, even we cannot distinguish liquid also. If liquid is there, we can say, of course, this is gas, this is solid, this is liquid. But we cannot say, this is propane, this is hexane, this is epane, like that. Okay? So the main thing, whether it is alkane, alkene or alkyne, to justify them. So if in a laboratory, one compound is given to you, they told you to check whether it is aliphatic compound or aromatic compound. Or another one, whether they are saturated or unsaturated. So students listen, aliphatic and aromatic compounds are saturated or unsaturated compounds are classified by igniting the compounds. Okay, so we have to take a small amount of compound in the spatula. Spatula means a spoon type. one material is there to pick that organic compounds. In spatula, take a pinch of that organic compound, whether it may be liquid or a solid. Gas we cannot take. So you just ignite or hold that spatula to the flame, non-luminous flame, blue color flame. Gas stove works so blue flame, it burns in a blue flame. That is non-luminous flame. So if we add that spatula to that non-luminous flame, then they ignite. That organic compound burns. If they burns without sooty flame, sooty flame means when we burn that what is a camphor, black color soot will eliminate it. You know that when we ignite that camphor, camphor means karpura. ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ಲ ನಾವು ಕರ್ಪೂರನ ಹಚ್ಚಿದಾಗ ಮೇಲ್ಗಡೆ ಬ್ಲಾಕ್ ಕಲರ್ ಫಾಗ್ ಹೋಗೋ ತನಕ ಮೀನ್ಸ್ ಹೊಗೆ ಹೋಗೋ ತನಕ ದಟ್ ಈಸ್ ವಾಟ್ ಸೂಟಿ ಫ್ಲೇಮ್ ಸೂಟ್ ಏನೋ ಕಾರ್ಬನ್ ಸೂಟ್ ಅಂತ ಕರೀತಾರಲ್ವಾ ಅದಕ್ಕೆ ಸೂಟಿ ಫ್ಲೇಮ್ ಇಟ್ ಇಸ್ ಮೀನ್ಸ್ ಚಿಮ್ನಿ ಅಂತೆಲ್ಲ ಇರುತ್ತಲ್ಲ ಮೆಟೀರಿಯಲ್ಸ್ ಇಂಡಸ್ಟ್ರೀಸ್ ಅಲ್ಲಿ ಮೇಲ್ಗಡೆ ಹೋಗ್ತಾ ಇರುತ್ತಲ್ವ ಕಾರ್ಬನ್ ಇಟ್ ಕನ್ಸಿಸ್ಟ್ ಆಫ್ ಕಾರ್ಬನ್ ಬ್ಲಾಕ್ ಕಲರ್ ಅದು ಹೊಗೆ ಹೋಗ್ತಾ ಇರುತ್ತಲ್ವ ಅದೇ ತರ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ಸ್ ನ ಬರ್ನ್ ಮಾಡಿದಾಗ ಸೂಟಿ ಫ್ಲೇಮ್ ಬರುತ್ತೆ ಇಫ್ ದ ಕಾಂಪೌಂಡ್ ಬರ್ನ್ಸ್ ವಿತ್ ಸೂಟಿ ಫ್ಲೇಮ್ ದಟ್ ಈಸ್ ಅನ್ಸ್ಯಾಚುರೇಟೆಡ್ ಇಫ್ ದ ಕಾಂಪೌಂಡ್ ಬರ್ನ್ಸ್ ವಿದೌಟ್ ಸೂಟಿ ಫ್ಲೇಮ್ ದಟ್ ಈಸ್ ಸ್ಯಾಚುರೇಟೆಡ್ ಅದು ಒಂದು ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಅಂತ ಆಯ್ತಾ ಇಫ್ ದ ಕಾಂಪೌಂಡ್ ಬರ್ನ್ಸ್ ವಿತ್ ಸೂಟಿ ಫ್ಲೇಮ್ ಮೀನ್ಸ್ ಇಟ್ ಎಲಿಮಿನೇಟ್ಸ್ a black color fog ಅದಾದ್ಮೇಲೆ ಅವಾಗ ಅದು unsaturated and without sooty flame means that is saturated that is in laboratory why I am telling means that is the one important sorry important test to distinguish saturated and unsaturated compounds okay So we will start with the first one, that is alkanes. So students, alkanes have the general formula Cl H2n plus 2. Okay, so in that classification, sorry, there is no classification, of course, nomenclature we already studied. Means alkanes have two types of structure, one is straight chain, another one is branch. We already studied the nomenclature of alkanes in a straight chain manner as well as in branch manner. Are you getting? So, give a simple example. CH4 means the name of the compound is methane. CH3 means two carbon atoms, that is eth, ethane. Correct? Means the functional group for or the suffix for alkane is ane. Here is alkane, ane. Okay, this alk means the carbon atoms. One carbon atom is methane. Two carbon atom means eth. This alk group A, ethane, methane. Similarly, CH3, CH2, CH3, that is propane. We already studied this about the nomenclature. So if branched, if I take an example, CH3, CH, CH3, CH. How do we name this? Initially, we need to select the parent chain. So this is the parent chain. Next, numbering either from left to right or right to left. It is 1, 2, 3 and 1, 2, 3. In both the case, this substituent will get in position 2 only. So any one side of the numbering is correct. Then this is what? 2-methyl. This group is called as what? Methyl group. 2-methyl propane is the name of the compound. Correct? So another one, if you want to take CH3, CH, So this type of compound is the, no doubt this is the parent chain. And this one is the substituent. Okay. So there is a two way of numbering. One is left to right, another right to right. So now start numbering from here. 1, 2, 3, 4, 5. From here 1, 2, 3, 4, 5. So students, from left to right, it is this CH3 will get the second position. From right to left, it is getting fourth position. So which one is the most preferable condition to number? Left to right. Because the substituents should get minimum value. And then this is 2-methyl. How many carbon atoms are there? 5. Means pent. This is how to name the branched alkanes. Understood? And already we discussed lot of examples regarding the nomenclature of alkanes, alkenes and alkynes in the previous chapter. Okay, so I'll continue with the next one. Means physical properties and their preparation, everything. So before going to that, so students, I already explained isomerism in this type of compounds. Isomerism of alkanes means it explains chain isomerism. This alkane shows chain isomerism. What is chain isomerism? Chain isomerism. The compounds having same molecular formula but differ in parent chain or differ in number of carbon atoms in parent chain. Understood? Here I write the compounds having same molecular formula but differ in parent chain called as chain isomers, and the phenomenon is called as chain isomers. I'll take an example here. One is CH3, CH2, CH2, CH3. This is N-butane or simply butane. N means normal. Next, C, H3, CH, CH3, CH3. This is isobutane. Iso means secondary carbon atom. Okay, listen, if I write the name in IUPAC manner, this is butane. This one is 2-methyl propane. So students, here if you count the number of carbon atom, that is 1, 2, 3, 4 carbon atom, C4, 3 plus 2, 5, 5. That is C4H2. Here also you count 1, 2, 3, 4 carbon atom, C4, 3 plus 3, 6 plus 3, 9 plus 1, H2. In both the case, the compounds having same molecular formula, C4H2 and CH2. But differ in what? Differ in parent chain. Here the parent chain is butane, here the parent chain is propane. It is different. This is one of the example for chain isomerism. Another one if you take, that is C5H, C5H12. So listen, one is CH3, CH2, 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 CH3. That is pentane. So another one, CH3, CH, CH3, CH2, CH3. This is 2-methyl butane. Another one, CH3, 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 CH3. This is 2,2 dimethyl propane. Okay, so students here, of course, straight chain is the parent chain. So pentane here, this is the parent chain. So butane here, this is the parent chain. So propane means here also molecular formula C5H12. Here also molecular formula C5H12. So the compounds having the same molecular formula but differ in the parent chain. Here it is pentane, here it is butane, there it is propane. Okay, this type of isomerism is exhibited by alkanes. Understood? So the next one is the preparation methods. Next one is preparation of alkanes. Initially, we will study the preparation of alkanes, later physical properties, later chemical properties. Okay? So, preparation of alkanes. That is from, the first one is from unsaturated hydrocarbons. From, especially you take hydrogenation of unsaturated hydrocarbons. Initially, I will write the methods first. How many methods are there? Second one, reduction of alkyl halides. Reduction of alkyl halides. Third one is Woods reaction. Third one is Woods reaction. Okay. Then the fourth one is from carboxylic acid. So this is always electrolysis or electrolytic method. These are the four methods of preparation of alkanes from these compounds. From hydrogenation of unsaturated hydrocarbon, reduction of alkyl halides, Woods reaction, from carboxylic acids. Okay, so let's discuss one by one. Remember, all these reactions are important for humans, any one. And among them, this is very, very important as it is a neighbor reaction like Woods reaction. Woods was the scientist who introduced this reaction. Are you getting? This type of neighbor reactions are very, very important rather than this. But all are important for 2 marks. This type is very important. Understood? Keep, because this is very important chapter. I am not telling it is tough. It is very important. Consists of only reactions. Very easy they are. Once you know the general reaction, that is quite easy to understand. General reactions was there. Okay? So we will discuss one by one. From hydrogenation of unsaturated hydrocarbons. So students, you know that unsaturated hydrocarbons are 2 types. One is alkanes, another one is alkynes. Initially I explained in the classification. Correct? Alkanes and alkenes. Those are examples for unsaturated hydrocarbons. So initially I will take alkenes. Okay, so students listen. I'll take the general formula RCH double bond CH2. This R may be hydrogen, CH3, C2H5, etc. This R may be that is hydrogen, RCH3, RC2H5, etc. R means it must be the general reaction. Later I will explain how to substitute R. So this is what? And just drop this. This is alkene. This alkene undergoes what? Hydrogenation. Hydrogenation means addition of hydrogen. Okay? Hydrogenation means addition of hydrogen. Remember, I will just to give an idea about this. Hydrogenation means addition of hydrogen. Next listen. Dehydrogenation. That is removal of hydrogen. Understood? And remember, hydration. Addition of water. Dehydration. Dehydration means what? Hydration means addition of water. Dehydration means removal of water. Okay? Next, halogenation. Addition of halogen. Okay? Next, dehalogenation. Means what? Dehalogenation means removal of halogens. Okay, next. Hydrogenation means addition of hydrogen. This hydro represent hydrogen and another one is what? Halogen. Hydrohalogenation means addition of hydrogen and halogen. Hydrohalogenation. Next, dehydrohalogenation means what? Removal of this hydrogen and halogen. Okay. Next, oxidation. 3 rules are there. One is addition of hydrogen, addition of oxygen, or removal of hydrogen, or loss of electrons. This is oxidation. Remember. Another one is reduction, just opposite to this. That is removal of oxygen. Next, addition of hydrogen. Or loss of electron means opposite is gain of. Remember this. These are oftenly using terms in this organic chemistry. Remember this. Don't forget. Okay? Understood? So these are very, very important for you. Hydrogenation, because I often going to use here hydrogenation, halogenation, hydration, dehydration, like that. So you need to remember this. Understood? Understood? Listen. So here, whenever this addition of hydrogen takes place, we need to use platinum or palladium or nickel as a catalyst. Okay. So here what happens? Here R is there. Here C, H, double bond, CH. So students, addition reaction always takes place where the double bond is present. Double bond is present here in between CH and CH2. Means this is changes to a single bond by the addition of both hydrogen atoms. That is R, CH2, CH3. And right here, that is R, CH2, CH3. This is alkane. Listen, how to write alkene? This alkene undergoes what it is, addition of H2 means hydrogenation. Are you getting? Alkenes undergoes hydrogenation. This is in presence of platinum, palladium or nickel as a catalyst. Alkenes undergoes hydrogenation in presence of platinum, palladium and nickel as a catalyst, forms alkanes. Understood? Next listen. Example 1. So I told you this R can be replaced by hydrogen or CH3, C2H5, etc. So initially I will go with H, that is H, CH, double bond, CH2. So students, this together we can written it as like CH2, right? H, CH2 are using heating. This is HCH, don't confuse. Here hydrogenation takes in presence of what? Platinum, palladium and nickel as a catalyst form. In the place of R, H is there. Just compare the general reaction. In the place of R, H is there. That is CH, CH2, here H, here H. That is equal to CH3 single bond CH3. CH3 single bond CH3. Correct? So this is ethene. This is ethane. How do you write? So listen, in the place of alkene, you take ethene. So ethene undergoes hydrogenation reaction in presence of platinum, palladium and nickel as a catalyst forms alkane. In the place of alkane, replace ethane. Are you getting? This is the way to write the reactions in a statement. Understood? This is the example. And remember, for you, just to replace this R group by CH3, homework, HW I am telling, just replace R by CH3 group and R by C2H5. C2H5 means you just take CH2, CH3. This is bonded. This should be bonded to this. Understood? Just replace R by CH3 and R by CH2, CH3. Do it yourself. In the tomorrow's class, I will continue with the next instructions. Thank you.